My name is Andres.
My name is Gavin.
My name is Diego.
And my name is Alexander.
And today we will be teaching you about 1D kinematics.
1D kinematics is measuring projectiles using vertical or horizontal length.
In this case, we're going to be using the vertical motion of a ball to calculate the time and its velocity final. In order to find the solutions of 1D kinematics, you need to solve for 5 vectors.
Those 5 vectors are acceleration, velocity initial, velocity final, displacement, and time.
So the second variable we need to know is velocity initial. Because I'm dropping the ball from a rest position, the velocity initial would be 0 since I'm not applying any other force. I'm just letting it drop. Although the initial velocity is 0, there is another force that attracts the ball to the floor, which is gravity, which can be expressed as negative 9.81 meters squared.
Since Alexander measured this, which is the height, in terms of centimeters, 217, we have to convert it to meters because physics only works in terms of meters. So it is 2.17 meters. Now knowing all the 5 variables, now we plug it into a kinematic equation known as the displacement formula, which is displacement equals velocity initial times time plus half times acceleration times time squared. Since the velocity initial is 0, when you multiply by time, it cancels out and gives you 0. So the displacement function is actually 1/2 the acceleration multiplied by the time squared. We know our acceleration is 9.8, so when you divide that by 2, you get 4.9 t squared equals 2.17 meters. The next step is to divide 2.17 meters by 4.9 to leave t alone, and then you find the square root of your result.
So after plugging in all the variables, like Gavin said, into the equation, we got 0.67 seconds. So now we will carry on with the actual experiment by dropping the ball from the height to the ground. And in doing this, we can check if our calculations were correct, which is about 0.67 seconds. And Gavin will start a stopwatch from the moment I drop the ball to when it hits the floor. So
after timing it, we got about 0.69 seconds, which is almost the same thing as 0.67, about 0.02 seconds off.
As shown through the experiment, we've successfully proved the importance of 1D kinematics.
Since the times were virtually the same, it has been shown that 1D kinematics can be used in an everyday situation and is useful.